Okay, so now we're going to multiply rational expressions in part 2 where the factors are not monomial factors. So remember in the last video, if you look at our problems, all of these factors, all of the factors were monomial factors. So look at number 2, they were monomial factors. You had an 8, you had an x, you had 5 factors of x here, you had a 2, you had a 4, you had 2 factors of x, and so on. So they're all monomial factors. Now in this video, in this lesson, we're going to learn how to multiply and simplify rational expressions where the factors are not necessarily monomial factors. They could be binomials, they could be trinomials, they could be a polynomial with 4 terms. But everything you've learned in the previous chapter dealing with factoring is going to be used here. Okay, so for example, let's look at this example. So we're going to multiply. So remember, it's going to say multiply and simplify. Multiply and simplify. All right, so number 1, x divided by 2x minus 14 times x squared minus 7x divided by 5. All right, so now if you look at your numerator, here's a monomial and here's a monomial. But these are not monomials. These are binomials. So you're going to have to remember that in the previous chapter, you want to make sure that your polynomials are factored, so that way you can reduce your common factors. All right, so the first step is to, if you want to write this as steps, first step is to factor all polynomials. All right, so you're going to factor all polynomials in both numerator and denominator. So this is a monomial, so I'm done with that one. Now here you have an x squared minus 7x. Remember, the first step to factoring polynomials is to remove or to factor out the GCF. So the GCF here for x squared minus 7x is x. So I get x over, and over here the GCF is 2. So I get x divided by 2 times x minus 7. So I wrote 2x minus 14, so I factored 2x minus 14 as 2 times x minus 7. So remember, you can always check yourself using the distributive property. 2 times x is 2x, 2 times a negative 7 is a negative 14. Over here, I'm going to remember the GCF here is x, so I get x times x minus 7 over 5. All right, so I did the first step. So the first step is to factor all polynomials. The second step is to reduce or divide out common factors. Okay, so if you look at the x occurs as a factor down here. Does x occur as a factor in the denominator? The answer is no. So because your factors are 2, this factor is x minus 7, and this factor is 5. So don't confuse this x with this. This is not a factor. X is not a factor. X minus 7 is a factor. All right, so that's one factor. All right, so the same thing here. Here's a factor of x. It does not occur as a factor anywhere down in the denominator. Now, if an x minus 7, does x minus 7 occur as a factor in the denominator? The answer is yes, right here. So just as we did in this, when we discussed this, just see right here in the previous lesson, just like we did this, we can reduce the x minus 3's. See, x minus 3 divided by x minus 3 is the same thing as 1 over 1, which is 1. So when I reduce this, when I cross these out, just remember you're left with ones in their places. You're left with a factor of 1, because x minus 7 divided by x minus 7 is 1. Anything divided by itself is 1. X minus 7 divided by x minus 7 is 1. And that's all you can do. There's nothing else that you can reduce or simplify. So we simplified this. So simplify is the reducing, dividing out part. And also you want to write as a one fraction. So don't leave your answer like this. You got to say x times 1 is x squared. You got to write as one fraction. So I'm going to go ahead and put write as a product, one fraction. Okay? So 2 times 1 times 5 is 10, and there's your answer. So that's number 1. Number 2. All right, suppose we had 6x plus 6 divided by 5 times 10 divided by 36x plus 36. So 6x plus 6 divided by 5 times 10 divided by 36x plus 36. So remember, the first step is to factor all polynomials. So these are monomials. I'm going to leave them alone. 10 and 5 is a monomial, so leave them alone for right now. I'm just doing the first step. Okay, now in that first numerator, I can factor out a 6. The GCF is 6. Always make sure you use the GCF. So I get 6 times x plus 1 divided by 5 times 10 divided by, over here, this binomial, I can factor, the GCF is 36. So 36 times x plus 1, because x times 36 is 36x. 36 times a positive 1 is a positive 36. All right, so I did the first step. First step is to factor all polynomials. Second step is to reduce or divide out. So in other words, see this x plus 1s, I can divide those out because they're exactly the same thing. So it's kind of like saying x plus 1 divided by x plus 1 is 1 over 1, which is 1. But it's a good idea. It's a good idea to actually, when you divide them out, they really need factors of 1s in their places. Because x plus 1 divided by, see if I wrote as one fraction, divided by x plus 1 is 1 over 1, which is 1. Now I'm going to reduce the 6 and the 36. See, this factor of 6 I can reduce with this 36. So I'm going to say, and remember, when you reduce, always use the greatest common factor. When you reduce, use the GCF. So don't say 2 into 6 and 2 into 36, because it's not going to help you at this point. I mean, it can, but you're not done. You're going to have to reduce it some more. So if you use the GCF, the greatest common factor, you can save yourself a couple of steps. So I'm going to use 6. 6 into 6 is 1. 6 will go into 36 6 times. So that's what I have so far. So remember, it's kind of like saying 6 over 36 in a previous course, and you're asked to simplify or reduce, you get 1 over 6. Now, if you had done this, if you had said 2 into 6 is 3, 2 into 36 is 12, and you say 3/12, well, you should recognize that 3 and 12, they still have a 3 in common. So 3 into 3 is 1, 3 into 12 is 4. I'm sorry. Yeah, 4. So that should be a 4 right here. Oops, sorry, I did something wrong somewhere. 36, I said 2, right? Oh, sorry, right here. 2 into 6 is 3. 2 into 36 is 18. And so you get 3, 6. 3 18, so that's 1 6. All right, so that's 6. So I kind of messed this up here. All right, but that's the idea you're going to use here. So if you look at the 10 and the 5, I can reduce those. 5 into 5 is 1. 5 into 10 is 2. And then it kind of gets a little bit messy. Now, some of you are going to recognize, well, I still have a 2 and a 6, so I can reduce that. And you can. So you can say 2 into 2 is 1. 2 into 6 is 3. Some of you may not have seen that so far. So what you probably would have done is this. So you can reduce at this point. But some of you may have said, well, I'm going to just go ahead and multiply this out. And there's nothing wrong with that. 1 times 2 is 2. 1 times 6 times 1 is 6. All right? But then, just like we did here, you got to remember from last semester, 2 6 is not simplified, because remember, you got to simplify. So 2 6, they both have 2's in common. So 2 into 2 is 1. 2 into 6 is 3. So the answer is 1/3. All right, so that was number 2. Number 3, suppose we had m plus n squared divided by m minus n times m divided by m squared plus mn. All right. So again, first step is to factor all polynomials. Now this is a monomial, so I'm going to leave it alone. Now this right here, see that m plus n squared? Remember what that means. That means m plus n times m plus n. So if you need to rewrite it, it does help. For some students, it does help if they rewrite. See, you have a binomial squared. So that means the base, which is n plus 1, times itself. All right, now my denominator, I can't, the GCF here is 1, so I can't do anything to that. So that's m minus n. The numerator is a monomial, leave it alone. Now the denominator here, the GCF is m. I can factor out an m. So when I do that, I get m times m plus n. So that's what you get, because m times m is m squared. M times a positive n is a positive mn. All right, so I did step 1. So step 1, everything is factored. Now, step 2 is to reduce or divide out your common factors. So you see this first factor, m plus n? Do I have an m plus n occurring as a factor down there? The answer is yes. So I can divide these out. Now remember, when you divide them out, you're left with ones in their you're left with factors of 1 in their spots. Because remember, m plus n divided by m plus n is 1 over 1, which is 1. It's kind of like saying 9 divided by 9. 9 goes into 9 one time. 9 goes into 9 one time. See, 1 over 1. So you get 1. All right. Okay, now my next factor is m plus n. Do you see an m plus n is occurring as a factor down there? No, you don't. Now, it's not this one because that's m minus n. Now, my next factor is an m. Do you see an m occurring as a factor by itself down there? The answer is yes. It's this one, not this one, because this is not a factor of m. That factor is m minus n. Here's your factor that's just m. So you can divide those out just like you did these. So you're going to say 1's 1. Because remember, m divided by m means 1 over 1, which is 1. M divided by m is 1. M divided by m is 1. So that's how you get this 1 over 1. And that's all you can do. So then you have 1 times m plus n times 1, which is m plus n. Here you have m minus n times 1, which is m minus n. And so there's your answer. Now again, just remember, you can't cancel out. Some students like to use the word cancel out. You can't divide out these m's because this is not, m is not a factor. Your factor is an m plus n. So remember, factors are separated by products. That's not a product here. That's an addition symbol. So m plus n is a factor. M minus n is a factor. Those factors are different. They're not alike. All right, number 4. All right, so you have x squared minus 25 divided by x squared minus 3x minus 10 times x plus 2 divided by x. All right, so this is what we get. Okay, so now let's factor what we can. So the numerator here, that's the difference of two squares. So we get x minus 5 times x plus 5. Over here, the GCF is 1. It's a trinomial, so remember, you're going to go directly to the two binomials. And remember your signs. The last sign's negative, so that means these signs in here are going to be different. And you want the outer and the inner to add up to be a negative 3x. All right, so the thing that's going to work is going to be, let's see, I'm going to need a negative 5 and a positive 2, and that works. You can always trick yourself. X times x is x squared. Negative 5 times a positive 2 is a negative 10. The outer is 2x. The inner is a negative 5x. When I add them up, I get a negative 3x. Over here, x plus 2, I can't do anything with. And then here's my monomial factor, x. That's where I'm at. Okay, so let's look at your factors and see what we can do. Always start with the first factors. Now make sure you know what your factors are. My factors are x minus 5, x plus 5, x plus 2, x minus 5, x plus 2, and x. All right, so x minus 5. Does x minus 5 occur as a factor down there? The answer is yes. So I'm going to divide those out. Remember, I'm dividing out, so which means that I'm left with factors of 1 in their place. So all this discussion right here is what we're referring to. My next factor is x plus 5. Do I have any other x plus 5s occurring as a factor down there? The answer is no. My next factor is an x plus 2. Do I have an x plus 2 occurring as a factor in any of my denominators? The answer is yes. I can divide those out. I'm left with factors of 1 in their place. and that's all you can do. You don't have any other factors of in the numerator that you can reduce in the denominator. Again, don't be careful. Don't say this x will reduce with this x, because this x right here that I'm pointing to, that's not a factor. Your factor is x plus 5. All right, so 1 times x plus 5 times 1. So remember, the next step is to write as a product of fractions. Is x plus 5. My denominator, 1 times x, is x. And there's your answer. All right, number 5. Okay, number 5. Okay, so number 5, you have x squared plus 6x plus 8 divided by x squared plus x minus 20 times x squared plus 2x minus 15 divided by x squared plus 8x plus 16. All right, so here we have all trinomials. The GCF in all of them is 1. So we're going to have to do some work. We have to figure out what all these binomials need to be. All right. Now, it is possible that you can't factor some of them, but I'm going to assume we can factor all of them. So I'm going to go ahead and put 2 binomials in each of their spots. Okay, so let's see. This one, x squared plus 6x plus 8, based on what we learned in the chapter dealing with factoring. So that's an x, that's going to be a 4 and a 2, and then a plus plus. So that is this. You can always check yourself. Here, x times x is x squared. I need a negative 20, and the out and the inner need to add up to be an x. So that's going to be 5 and a negative 4. So that's what I get there. Over here, x times x, I need a negative 15 for the last. I need the out and the inner to add up to be 2x. So that's going to be a positive 5 and a negative 3. And over here, x and x, last sign's positive. Both signs in here are going to be the same. They're going to be that little sign. And the only thing that will work would be 4 and 4. All right. So I factored each of those trinomials. Now I'm going to reduce my factors. I'm going to simplify. X plus 4 is my first factor. Is there an x plus 4 in the denominator? Yes, there are 2 of them, but I can only use 1. So I'm going to divide these out, left 1s in their place. Make sure you put 1s there. My next one's x plus 2. Does x plus 2 occur as a factor in the denominator? The answer is no. The next factor is x plus 5. Does x plus 5 occur as a factor in the denominator? The answer is yes, right here. So divide those out, and I'll put 1s in their place. The next factor is x minus 3. Does x minus 3 occur as a factor in the denominator? The answer is no. So then your answer is going to be, now leave them as factors. Leave them as factors. So it'll be x plus 2 times x minus 3 divided by x minus 4 times x plus 4. So x plus 2 times x minus 3, because 1 times 1 is 1. And then over here, 1 times 1 is x minus 4. 1 times x plus 4 is x plus 4. Now don't use a FOIL method and multiply this out. Leave it alone. So you want your answer in factored form as much as possible. So I'll just make a little note right here that says leave answers in factored form. Okay, so leave answers in factored form. So you got to leave your answers. Leave it as this. Don't FOIL it out. Just leave it alone. You're done. All right. Okay, let's look at number 6. All right, so we have, let's see. Okay, we have 3x plus 4y divided by x squared plus 4xy plus 4y squared times x plus 2y divided by 2. All right, so let's see, the GCF here is 1. Now here I can factor this. So the numerator is going to stay the same as it is. Down in this denominator, you're going to have xx. I'm going to need 2y and 2y. So plus 2y plus 2y. So x plus 2y times x plus 2y is going to be this. Over here, that's times x plus 2y. GCF is 1. Here, that's a monomial, leave it alone. And then just reduce your common factors. So 3x plus 2y is a factor. Don't say 3x is a factor because of that plus symbol. All right, so remember, factors are separated by products. So this 3x, don't say it's a factor because if you do, you're making a mistake because you're adding it to this other one. This is not a product. So altogether, this numerator is a factor. Here, this numerator is a factor. It's not an x and it's not a 2y. It's x plus 2y. This is not a multiplication symbol. All right, so 3x plus 4y is a factor. Do you see 3x plus 4y occurring anywhere down here as a factor? The answer is no. Now, remember our discussion, 3x plus 4y is a factor. So if you think that 3x is a factor and 4y is a factor, you're going to mess up because you're going to do this. You're going to say 2 into 2 is 1, 2 and this 4 is 2, and that's wrong. Altogether, that's one factor. Okay? All right, now my next factor is x plus 2y. Do you see an x plus 2y occur in this factor down there? The answer is yes. There are two of them. I can only use one. So divide them out. You left ones in their place. And that's all you can do. So my numerator is 3x plus 4y. My denominator is x plus 2y times 1 times 2. So that's 2 times x plus 2y. And don't multiply this out. Leave it in factored form. So there's your answer. And number 7. Now, just to be clear, if you did distribute, there's nothing wrong with that, but leave it in factored form. It's better if you leave it as it is. So if you want to say 2x plus 4y, that's fine, but leave it in factored form. It is better if you do that. Okay. All right, number 7. Suppose we had, let's see. All right, suppose we had this. Suppose we had 5x minus 20 divided by 3x squared plus x times 3x squared plus 13x plus 4 divided by x squared minus 16. All right. So we're going to factor the polynomials. And we're going to get, this is going to be, we can the GCF here is 5, so we're going to get 5 times x minus 4. Over here, the GCF is x. I'm going to write it as x times 3x plus 1. All right, 3x plus 1. Always check yourself. X times 3x is 3x squared. X times a positive 1 is a positive x. Here, let's see, 3x, x. This is going to be the 4, this is going to be a 1, and then plus plus. So 3x squared plus 13x plus 4 is going to be this. You can always check yourself. 3x times x is 3x squared. Positive 1 times a positive 4 is a positive 4. When you add the outer and the inner, the outer is 12x, the inner is 1x. When you add them up, you get 13x. And in this denominator, that's the difference of 2 squares, so x minus 4 times x plus 4. All right, we start reducing or dividing out our common factors. My first factor is a 5. I don't see 5 occurring as a factor anywhere in my denominators because that's an x, that's a 3x plus 1, that's an x minus 4, and this is x plus 4. My next factor is an x minus 4. Do I see an x minus 4 occurring as a factor down there? The answer is yes, it's right here. So I divide those out. Remember though, you're left with ones in their places. Put ones there. My next factor is a 3x plus 1. Do you see a 3x plus 1 is occurring as a factor down there? The answer is yes, it's right here. So divide those out. My next factor is an x plus 4. Do you see an x plus 4 occurring as a factor in the denominator? The answer is yes, it's right here. And that's all you can do. So the answer is going to be 5 times 1 times 1 times 1 is 5 over x times 1 times 1 times 1 is x. So the answer is 5 over x. All right, and that's going to be the end of this video. So we're going to do next in part 3 is we're going to look at division. So dividing polynomial expressions. So that's going to be the next part.